Hi guys, good evening everyone, and welcome back to 360DigiTMG's Domain Analytics program. And today is the fourth day of Domain Analytics. From the very first day that we have discussing about transportation analytics, how we can apply the machine learning algorithms or machine learning models when it comes to transportation analytics and transportation, particularly domain called transportation. How can we improve the transportation? Those we are discussing. And the very first day, that is what we have discussed. So on the first day, we have discussed applications. Applications of AI, or you can say machine learning, when it comes to transportation domain. And we have seen where we will be where we can improve the transportation system and how can we monitor whatever the goods that we are sending and how can we decrease the time. So especially when it comes to any economy, transportation plays very important role. So it is very necessary to improve the transportation system and the goods that we are supplying. So we have seen how can we monitor all those things using the machine learning and where we can improve those transportation that we have seen in very first day. And on second day, we have seen crisp ML methodologies. So what is crisp ML methodology? So irrespective of crisp ML itself, known as cross-industry standard process. Cross-industry, irrespective of any domain, that could be transportation, that could be health, that could be HR analytics, that could be agriculture, irrespective of any domain, cross-industry, irrespective of any industry, we will be doing the data science project using these phases only, crisp ML phases. In that, we will be having 6 phases. So what are those phases? From business understanding to deployment and monitoring. What we will be doing in each phase. In order to increase the accuracy of the model, we will be going through the crisp ML methodologies. So what are those different phases we'll be having? What we will be doing in that particular phase, that we have discussed on the second day. And then we have seen on third day, what are the data mining concepts we'll be having. So when it comes to machine learning, we'll be having 2 models, that is supervised and unsupervised, and we have semi-supervised as well, but nowadays it is gaining a momentum. But for now, we'll be having supervised and unsupervised, and we'll be having semi-supervised. But previously we have these 2 techniques. So we will be discussing these techniques only. What are the supervised, what are the unsupervised? I'll be giving you quick review when I start the unsupervised learning. So these are the things, what happens when it comes to supervised, how the data is processed, all those things that we have seen on third day. And when it comes to unsupervised, how the data will be pre-processed, all those things that we have seen on the third day. And then we have discussed about pre-processing techniques. Last class, we have discussed about pre-processing and EDA. What is pre-processing? Whenever we are collecting the data from different sources, that could be collecting the conducting the survey, or we are doing some web scraping from different websites. But in that, whenever we are collecting the data, in that case, we'll be having so many anomalies. What are those anomalies that we have seen in the last class? So that could be missing values. That could be dummy variables, or you can say duplicate data. That could be duplicate data, and there might be some these kind of data. All will be comes under anomalies. So how can we remove those anomalies? What are the different techniques we'll be having? That we have seen in the last class. And today we'll be taking one unsupervised algorithm. Unsupervised learning. We'll be taking one unsupervised algorithm and we'll take one use case scenario and we'll try to apply this unsupervised learning algorithm. What exactly the unsupervised? So whenever you are having the data and you don't have any label in it. Label means the output. Let's say I'm taking, like I've already discussed this, but let me give you a quick review about it, what exactly the unsupervised. When you have a data frame and you have a features, and if you don't have any output data, let's say COVID, what are the features will be having when it comes to when one person is infected with COVID? He'll be having headache, body pain, and he'll be having cold. He'll be having fever as well. So these are the different we'll be having, right? Based on these only we'll be deciding whether that particular person has a COVID or not. If that COVID column is also given, this is the output, right? So based on these features, we are deciding this output. If it is not given, if we are supposed to go through just features, based on those features, we have to cluster into different categories. One category, people who have a COVID positive. I mean, we are not directly saying there is a COVID positive. We are simply similar features. Who are having the similar feature, we'll simply categorize into different clusters. This is one cluster and this is one cluster. And both clusters are very different. Let's say normally what happens, the people who have a COVID and who doesn't have a COVID, those features will be very different, right? So like that, whatever the feature we are taking based on similarity, these cluster, this is one cluster and this is one cluster. All the features that is present in the cluster, these clusters should be similar, and all the features that we are collecting in this cluster should be similar, and when compared to each other, it should be very different. So that is how we will be doing the unsupervised learning. And when it comes to supervised, that when you have a labeled data based on those features, whatever the feature will be having, the same COVID case you can take, and you have a result, whether it is positive or negative, COVID positive or COVID negative. Based on the feature itself, we can say that that particular person has or got infected with COVID or not. If we have this output, we will be simply predicting. We will simply predict it. So this is the difference between supervised and unsupervised. Today class we will be taking the unsupervised learning. In that we are taking one algorithm called k-means. So in supervised we have so many algorithms, like we'll be having hierarchical clustering, and then we have association rules, recommendation engine. So these are all algorithms comes under unsupervised. So we will be taking k-means clustering algorithm and we'll try to apply using one use case scenario. Before that, we'll get into what is k-means, how k-means works, what is the mathematics behind it, what is the logic behind it. We'll see. Before getting into that, we'll see what will be the agenda for this session. Yeah. So what is the agenda for this session? We will simply go through what is k-means algorithm and how we can be applying that k-means algorithm using one use case scenario that we will see. So whenever you are talking about unsupervised learning, what is it? Machine learning technique in which models are not supervised using the training data set. So whatever the data that we are taking, if we don't have any labels, in that case, we are not monitoring it, right? We will simply pass in the data, and based on the data only, right after the pre-processing. First, we have to do the pre-processing. Right after the pre-processing, we are sending the data to the machine learning algorithm. Let's say it is here one machine learning that is unsupervised algorithm. Here we have unsupervised algorithm. What it will do, we are not splitting into train and test. It is not happens when it comes to unsupervised. We'll be doing when it comes to supervised. Here we won't be doing anything. We are simply right after the pre-processing, we'll sending the data to machine learning. What machine learning do? It will go through the data. Whatever the data will be giving or feeding to the machine learning, it will simply go through the data. Based on those data, it will try to find out the patterns. Whatever the data that we are feeding, it will go through and will try to find out the patterns. Based on those patterns, it will come up with rules. It will simply come up with rules. Those rules we will be using to whatever the new data that is coming to that machine learning algorithm. Based on these rules, it will be predicting what exactly that data is about, which cluster it belongs to or which group it belongs to. It will simply predicts. So this is the unsupervised algorithm. Instead of model themselves, find the hidden pattern. So we won't be having particular model. We don't be having any algorithm that is working behind it. Simply, we'll be feeding the data into the machine learning algorithm. Based on the data only, it will simply find out the hidden patterns and the insights from the given data. It can be compared to the learning which takes place in a human brain. Now, normally what happens? Based on things, I mean, whatever the incident that are happening to us, based on that only we'll be learning, similar to the human brain. So it will simply goes through the pattern itself. It goes through the pattern. We are not monitoring or we are not training that data at all. Simply goes through data frame itself, and it will come up with different rules. Based on those rules, it will be forming the groups. Based on the rules, it will be forming the group. This is unsupervised learning. Now, the goal of the unsupervised learning is to find out the underlying structure of the data set. Group that data according to similarities. Here, what is those similarities? All those things we'll discuss in the next slide. How can we finding the similarities between the whatever data that is presented? So whenever you're talking about the similarities in numerical data, we will be using the Euclidean distance. So if the distance is very small, in that case, those are similar. If the distance is too high, let's say this, consider these one only. Let's say this is one data and this is one data. And this is one more data. If I calculate the distance between these two, in that case, the data is, distance is very small. In that case, we can say that it is a bit similar, characteristic will be having. And when you compare to this one, here we will be having large distance. It won't be having any similarities between those two data points. Like that, we will be using the Euclidean distance. Euclidean distance means, let's say if you have two data points, and what is that? Distance between those two data points. How can we find out? X2 minus x1 whole square plus y2 minus y1 whole square. So whenever you are having two data points on the plane, it should be having some x coordinates and y coordinates, right? That is x1, y1, and one more data point will be having, that is x2, y2. The distance will be calling it as Euclidean distance, but here we won't be having just two, we'll be having multiple features. So this is how we will be calculating the similarity between two data points. What is that similarity? If you have a least distance, in that case we'll be considering as similar. If you have a high distance, in that case we will be considering that not similar. So you can see here we are simply giving the data of different features. Here we can see this is one tortoise, and this one is a fish, and this one is duck, tortoise, and duck. These are, what does that mean? We are giving different data. We are giving different data. We'll be having similar data also. So based on this, we have to do the clustering. We have to, based on this, see, tortoise will be having some features, fish will be having some features, and duck will be having some features. What are those features? For example, tortoise can live both on land as well as in water. When it comes to fish, it should be living in water only. It will, if we come out of that water, in that case, it will be die. Let's say these are the different data and their features, and we are feeding into the machine learning model. So what it will do, each data, I mean, let's say we are not giving just one. We will be having so many features according to, I mean, for the tortoise. Same, I mean, different, I mean, some more features will be having when it comes to fish. We'll be having some more features when it comes to duck. If we are passing through all those features, machine learning, what will do, it will simply go through all the patterns. So it will observe all the patterns. Based on those patterns, it will simply segregate. Let's say one feature, it came like it can be live, I mean, it can survive on both on the surface as well as in deep water. In that case, that feature belongs to what? If it is only survives on, you know, water, in that case, this feature is belong. That is one pattern. Here, it can only survive on land. In that case, it is one of the features. So based on feature, this is pattern. Feature means it is pattern. Based on these patterns, it will simply segregate into different categories. Now, we have created 3 categories. That means 3 clusters. 3 clusters, like that, we will be doing the cluster. Let's say these are the same. Tortoise will be having different features. We'll be having something else, and we have different data frames. Data will be having here also. We have some data here. We have some data. And then what we are doing, it will be calculating the distance between each and everything. Based on that, we will be forming the clusters. So these are similars, and these are whatever the data points will be having. These are similar, and these are similar. Like that, we will be forming the cluster based on the distance. When comes to k-means clustering, how these clusters are formed? Yeah, we'll go through that. How cluster will be formed when it comes to k-means. Right after the forming the cluster, it will be formed as different goods. We can simply name them. These are ducks, these are tortoise, these are fish, something like that. We can not these only. We will be having whichever data that you are having based on the picture. You can simply name those clusters. Those are the properties of that particular. Based on these properties, you can simply name them. Which feed, I mean, product, or that particular person, or that particular animal having that kind of properties. That could be any product, anything. So we can simply group them into different clusters. Now we will see how k-means clustering will be performed. So what happens when it comes to k-means? We have different clusters actually. Hierarchical clustering will be having. K-means clustering will be having. In k-means also we have so many. K-medoid will be having. K-means plus will be having. There are so many. Based on the linearity of data, we'll be having so many. But here we will be discussing about k-mean. K-means clustering. So what is the k-means? What happens when it comes to k-means algorithm? It is, k-means is one such unsupervised learning method that aims to group similar data points in cluster. All cluster will do the same, and k-means also similar. What it will do, based on the similarity, we will be finding the, whatever the similar feature or similar data points will be having, we will try to cluster them or group them. So how it is happens, we'll see. Okay. It is a centroid based algorithm where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of the distance between the data points and the other corresponding clusters. And it allows us to cluster the data into different groups and a convenient way to discover the categories and groups. So what unlabeled data, whatever the unsupervised learning we will be doing, we will be having we won't be having any labeled data. Without labeled data only we'll be doing the clustering. So when it comes to k-means, let's say this is the data frame we'll be having. let's say this is the data frame we'll be having. So what we'll be doing? Randomly, k value will be upfront. We have to pass the k value. So normally in hierarchical clustering, we would be having that based on the dendrogram. We will be deciding how many clusters are making sense. But here we have to pass k value, that is a centroid. At the very first, you have to pass centroids. How many centroids you want to pass? It's up to you. So if you want to go with 2, you can go with 3, you can go with 4, anything. So I'm giving here 2 centroids, or I'm giving 3 centroids. Let's say I'm giving 3 centroids. K is equal to 3. What happens when I mention k is equal to 3? Randomly, it will assign 3 centroids. All right, after I've mentioned upfront, we have to give k value. And how can we decide how many clusters are making sense? That we will be seeing in a minute. Whenever you're mentioning k is equal to 3, in that case, randomly it will assign 3 centroids. These are centroids, centroid-based algorithm, right? So, and then once centroid has been assigned, in that case, what we'll do? It will calculate the distance between each and every. Let's say this one is 1 centroid and this one is 1 more centroid. And it will find out the distance between each and every point. It will find out the distance between each and every point. What that data will be having. So based on those distance, it will find out which are the nearest to that particular centroid, that it will form as a cluster. And let's say here we found 1, here we found 1, here we found 1. In that case, it will be forming 1 cluster, and it might be forming something like it will be 1 cluster, and then it will be forming like 1 cluster, something like that will form. Right after forming the cluster, what it will do? It will find out the distance between all those data points in that particular cluster. It will find out the, let's say this is 1 cluster. It will find out the distance between all. It will be finding out distance between all. Right after finding the distance between all, it will calculate the mean. Right after that, it will calculate mean. This is centroid 1, you can say it is centroid 2, and it is centroid 3. It will calculate the mean of all. Once mean is calculated, whatever the mean value will be having. Previously, we have this centroid, randomly assigned centroid. Here it is. Randomly assigned centroid. Whichever the mean is obtained, the previous centroid will move to new centroid. Previous centroid will move to new centroid. And again, it will calculate the distance between all those points. Again, it will be finding the distance between all those points. And here also same, it will be finding the distance between all points. And it is also, again, it will be finding the distance between all those points based on the similarity or based on the distance. Again, it will be forming what? Clusters. Again, it will be forming the clusters. Based on those clusters, again, it will find out the distance between all those clusters. Based on all those clusters, again, it will calculate the mean. According to the mean, it will simply shift their centroid. Again, shift their centroid. Like that, it will keep happen. Like that, it will keep happen until and unless those clusters are stable. It will keep happen until and unless those clusters become stable. These will be called as convergence. So it will keep happening until and unless those clusters become stable. What that means? What is that means? Centroid won't move anymore. Centroid will be stable. Like that, we will be forming the k-means clusters. So what we are doing first? Whenever k is equal to 3, randomly we'll be assigning 3 centroids. Based on those centroids, we'll be calculating the distance between all those points. Whichever near, in that case, it will simply form 1 cluster, based on those cluster, it will calculate distance between all those data points will be having in that cluster. On those, based on those distance, will be calculated the mean. Whatever the mean that is getting, it will simply shift their centroid to that particular mean. Like that, it will keep happening until and unless those centroids will become stable. This is the k-means clustering. After that, whatever the cluster that we have found, we can simply name them, simply like this. We can simply name them based on those features. So this is how clusters will be found. Yeah. So what first we are doing? Initialize the centroid is equal to k. For each sample in the set of samples, we'll be giving k is equal. It could be any value. It could be 3. It could be 4. Any value that can be. Assign the sample to its closest cluster k based on the Euclidean distance. Once it is done, we have to assign this one. It will be calculated the distance. Based on those distance, it will be closest data point will be from cluster. Based on what? Euclidean distance. For each cluster in the set of cluster, recalculate the cluster centroid based on the mean of the samples in the clusters. Once cluster is formed, we will be finding the distance between all the data points to the centroid, the previous centroid, and then we will be calculating the mean of that. According to that new mean, we will be shifting from past centroid, previous centroid to the new centroid. It will keep happening, the same 2 and 3. It will keep repeating until and unless stopping criteria is fulfilled. What is the stopping criteria? It will become stable. The variance of each cluster, that is the sum of the square error. How far is that? What is the variance between two clusters that we'll be calculating. Repeat the step 1 and 5 to different initializing of clusters, centered position. Like that, we will be forming different clusters. Like that, we will be forming different. This is the way we will be finding the clusters using what? K-means. Why we name K-means? Since whatever the centroids, the new centroids will be forming based on what? Mean of those clusters. Mean of those clusters. Based on that only, we will be shifting the centroid. So what are the advantages of K-means clustering? So when you have large number of data sets, normally whatever the drawbacks when it comes to hierarchical clustering. What is hierarchical clustering drawbacks? Whenever you have more number of data, large number of data set, or you can say large data set, in that case it is not possible to go through those cluster or dendrogram. It is not possible to go through the dendrogram and decide how many clusters are making sense. Since when you have a large amount of data, those clusters won't be visible. To avoid that, we will be using what? K-means clustering. Large due to, whenever you have, large amount of data set, in that case, we can go with K-means clustering, and it is computationally inexpensive. What we are doing here? Just calculating the Euclidean distance. Other than that, are we doing anything? So we are not doing anything. So it is computationally inexpensive. Whenever there is not many computation, in that case, you don't require high-end machines. You don't require high-end machines. When you don't require high-end machines, in that case, you can decrease the cost and you can scale well with the large data. When we have a large data, in that case, we can easily able to find out how many clusters are making sense. And it is an appropriate method when you know the number of clusters to be drawn from the data set. Like if you are having good knowledge about that particular domain, if you have good knowledge about that particular domain, in that case, you can easily know, right, how many clusters are making sense. In that case, we can simply, here in K-means what we'll be doing, upfront we are giving the clusters, number of clusters, that are number of centroids. So if you know that, particular domain perfectly, in that case, you can simply decide how many clusters are making sense. So if you know the domain knowledge, in that case, you can simply go with the k-means clustering. So these are the advantages when it comes to k-means clustering. So what are the limitations? Yeah, upfront you have to give k value first. Outlier can have some strong influence on the result. Why is that? Outliers can have a strong influence on result. Why is that? Since we will be using k means. Means average. Whenever we are having k means, outliers will definitely impact. K means outliers can definitely impact. Initial centroid position have strong influence on results. You can observe whenever we are doing the adjustment of centroid, very first the centroid will have like a huge displacement compared to any other. So it will be having the high influence when it comes to on the result. And does not cluster well with the clusters of varying size and densities. When you have, in that case, we'll be doing the normalization. Since we have features and their ranges are very different, in that case, we simply go with the normalization and we can avoid that limitation. So these are the limitations when it comes to. So what are the key concepts for stability? So there is one more case. Okay, let's say there is one data point is present something like this. It's a data point like this. This Android 1 and this Android 2. You might be having some data points. Let's say if I'm calculating the centroid, new centroid for this, and this data point is coming into the first, and if I'm calculating the centroid for the second, I mean, right after the mean only I'll be doing that, right? You might be finding some data point, something like that. Each time it will be oscillating in between two clusters. In that case, you won't be getting any output. You are in infinite loop. It will keep oscillating in between 2 points only. So in that case, it will be difficult. So it will be, you will be getting into the infinite loop. You won't be getting any result. It will keep running. To avoid that, we can give number of iterations. We can simply give number of iterations that you want. Let's say if you are given number of iteration is equal to 50. In that case, what happens? Let's say it is you run into the infinite loop. If it is oscillating in between these two clusters at iteration 50. If this data point is part of this cluster, in that case it will become this cluster. On N50, the number of oscillations reached 50. In that case, if data point is in this cluster, and it will become this cluster, and that infinite loop will break. Like that, we can avoid that infinite loop. Convergence. A data point might keep oscillating between two clusters in each of the row, and algorithm will enter infinite loop. Address this by choosing the convergence. Convergence means number of iteration. Convergence criteria are specify maximum number of iteration. We can simply give convergence criteria. You can simply avoid that. So this is one of the concepts that we'll be having when it comes to k-means cluster. And then whatever the cluster variation will be getting. See, and one more when it comes to drawbacks, when it comes to k-means, each time you are running the algorithm, you will be getting the different outputs. Why is that? Let's say if you are considering just one data point, in that case, you'll be having one global maximum and you'll be having one global minimum. When you have just two data points, when you have multiple data points, what happens? It will be looking like this. So it doesn't know where we'll be having the maximum, global minima, where we'll be having the global maxima. If randomly you have taken data frame, in that case, it will be taken this from here. Let's say it is taken from there. So it will try to decrease that error rate. Whatever the error will be having, and it will reach this point, and it will consider this is the global minimum. But is it the global minimum? Here we'll be having the global minima. That is why whenever you do multiple iterations, each time you'll be getting different results. First, it might be taken from here, and then it will be taken from here, or it might be taken from here. So we have to do multiple iteration to find out the best results. And we have to compare cluster variation and within the cluster variation. This is the one cluster, and this is one cluster. We have to find out the variation between in the cluster and in between the cluster. Based on that, we can say whatever the clusters we are forming are feasible clusters or not. And based on that, we can say that, we can finalize that whatever the clusters we are forming are sum of the square error. We can find out the sum of the square. How can we find out the sum of the square error? Within the sum of the square error will be having when you find out the distance between it in between those clusters. If this within the sum of the square is less, in that case, all those clusters are packed. When you have between the sum of the square, if you have between the sum of the square is high, in that case also we can say whatever the cluster that we have formed is good cluster. So it should be cluster in between in the cluster, all those data points should be packed, and when it comes to different cluster, the data point should be as high as possible. And here we'll be having one use case scenario. What is the use case scenario? I'll tell you. I'll briefly give you the example which data set we are talking about. So we have some different features. What is the objective? When it comes to objective, we have different features of car. When it comes, we are working on the transportation data analytics. So we are taking the data related to the transportation. That is what we have some vehicles. So based on the features of the vehicle, we have to find out which country that featured vehicles will be used. In which country we'll be using? See, when it comes to roads of different countries are having different features. Let's say in India, normally what people prefer, which is having the high mileage, and here roads are also not that good. When it comes to in a village, you won't be getting good roads. In that case, even though if you drive something like Ferrari, in that case it doesn't work. So based on the road quality, countries are going with different featured cars. So we'll be having different features, and then we have different countries. Based on the feature, we have to segregate which countries are using these features. So that is the business objective of the use case scenario that we will be taking, and we'll get into that, and we will see how we can do the segregation using the K-means cluster. So normally it is not possible to visualize, multi-dimensional data. Right? So hence we are taking a data set of 7 to 8 features we'll be having. In that case, you need 8 dimensions. So it is not possible to visualize. Before that, I'll be taking one dummy toy data and try to explain how K-means clusters are formed. For that, I'm importing the pandas, I'm importing NumPy, and then I'm importing the matplotlib. For the visualization, NumPy for mathematical, that is, will be calculated the distance, right? So I'll be doing that using the NumPy, and then have pandas in order to do any changes in the data set. I'll be using the panda, or you can simply say to do the manipulations. So here I'm creating the 50 data sets. That's random data sets we'll be having. I'm giving a feature name as X and Y, and I'm creating one font as data frame. Here, I have empty data set. This is one feature, and this is one more feature. In that, I will be adding this new data points X and Y. So I'm assigning that. See here, we will be having two data points. One is X and one is. Hence, we have just two. In that case, we can easily visualize using the 2D plane, right? So this is our visualization. These are the different data points we'll be having. I want 3 clusters. Upfront, I'm passing n is equal to 3, and I'm applying k means cluster. So here you can see we have formed 3 clusters, right? Since it is just 2 data set, 2-dimensional data set, in that case you can easily visualize it. You can easily visualize it. But when it comes to multi-dimensional data, it is not possible to visualize those. In that case, you won't be able to see clear clusters. Like we'll be having here, we won't be able to see clear clusters, but you might observe those colors. Based on that, we can assume that this car is belong to this country, and we'll be naming that so that you can easily understand. Okay, let me clear this. Okay. So again, I'm importing the pandas and numpy. Here I'll be having data set, that is car data set. We'll see what is the car data set here. So I have already labeled, but I need to remove that label since we will be using unsupervised data set, right? So it is not necessary. So these are the data frame we'll be having. I'm simply converting the labeled data into unlabeled data, you can say. Since we are using very base model, guys, if you want to improve, you can improve. This is very base model. So here we'll be having what are the features we'll be having: miles per gallon, cylinders, how many cylinders that particular car has, and inches, the length of that particular car, you can say, HP, horsepower of that particular car, and what is the weight of that particular car in pounds, and how much time it is taking. How much time it is taking to reach 60 miles per hour, and which year it is manufactured. You can say the brand manufacturing started. You can say these are the. You can simply observe based on the data set. Also, we can get some insights about that particular. See here. You can see here. When it comes to USA, the miles per gallon is just 50. Here we have 24, and when it comes to Japan, you can observe miles per gallon is. You can simply compare these two countries. When it comes to USA, they will be having high GDP per capita. In that case, even though it is 15 miles per gallon, it doesn't matter. They can bear that one. When it comes to Japan, they will be having less, per capita GDP. In that case, they are going with a bit high miles per gallon. So how much mileage it is giving, especially when it comes to India as well, we'll be going with high miles per gallon. So how much mileage it is giving? You can some differences you can do using the data set itself. So this is the data frame I'll be having. Now I'll be doing. So I'm just removing that the label data. So for now, it is not necessary. So I'll be taking which are the feature: miles per gallon, cylinders, and these are the features I'll be taking. That is not necessary, even though if you want to take, it doesn't affect much. Yeah, I'm simply checking whether I have any null values or not in our data frame. So here we have just five null values in the weight and in cubic inches. For that, I'll be using one code to remove all those. Now you can see you don't have any null values. You can do some of pre-processing like outliers and all. Since it is very base model, I'm simply going with how we can apply the machine learning algorithm when it comes to transportation, so that you will get an idea where exactly we'll be using and all. And here I forgot to mention, while we are deciding how many clusters, upfront we are passing k is equal to 3, that we have passed, right? You can pass anything, k4 or 2, 3, 4, 5, something like that. Upfront we are passing something, but are those the feasible one, or are the best clusters we'll be forming? No. Just to start the algorithm, we'll be giving some, but how many clusters are making sense? We can find out using what? Scree plot. Using the scree plot, we can find out how many clusters are making sense. Here, I'm taking the range from 1 to 11. So, and we'll be taking the within the sum of the square. This is the total sum of the square, you can say, TSS. I'll be taking the TSS, that what is TSS? Between the sum of the square we'll be having, plus between the sum of the square we'll be having. That will be taking on the y-axis, and x-axis I'll be taking the k value, that are number of clusters are making sense. Based on that, I'll be plotting my scree plot, that we'll be also calling it as elbow plot. Elbow plot. Using this scree plot or elbow plot only, we'll be deciding how many clusters are making sense. So which one we will be taking? Mostly we'll be taking here. I mean, wherever it is the elbow, looking like elbow, that we'll be considering as the best cluster. But what I recommend, what I suggest is go with other as well. If it is 3, in that case, go with 2 and go with 5 and check, go with 4 and check 2, 3, 4, wherever you are getting the good, I mean, meaningful cluster, whatever the meaning average will be having or making sense. In that case, you can go with that only. So that is what I can suggest. See, here will be the number, how many number of clusters you can form? Up to 11. In that, we are just taking 3, right? So much time saving. So you can simply go with that. So now I'm plotting. This is for that. I'm importing k-mean. Since we are working on the k-mean, so that is cluster that is present in sklearn package. From sklearn, what I'm importing? Cluster. In that, I'm importing the k-means. It is one algorithm. Whatever the algorithm, most of the algorithm that we'll be having, everything will be importing from sklearn only. Most of the algorithms. Import k-means, and then we'll be forming scree plot. So this is how scree plot look like. So wherever it is looking like elbow, in that case, you can take that only as a best cluster. What I recommend, here we will be giving the best cluster is equal to 3 only, but you can go with 2 and you can go with 4 and you can check all 3, whichever giving the best one, you can simply go with that clusters only. You can check 2, 3 and 4. So I'll be taking 3 since I have worked on it. I know 3 will be giving the best. So I'll be simply giving k is equal to 3. That is number of cluster I want. I'll be taking 3. And I'm using here k-means plus plus. You can use k-mean as well. We'll be getting the similar results. And here I'm taking the maximum iteration is equal to 100. Why we need to take maximum iterations? It's very, very rare case. I mean, not frequently happens but we have to take the maximum iteration. You might get into the infinite loop, right? To avoid that, I'm giving maximum iterations are 100 and I'm fitting that whatever the x value that we'll be having, whatever the features that I am considering, I'm fitting into the cluster. I'm fitting into the clusters. So these are the clusters that are formed. You can simply click on it. How many clusters we have? 3 clusters, 0, 1, 2. These are the 3 clusters. You can simply check the data set. How many data points will be having? Very less data points will be having. Right? So the very first will be belong to number 2, something like that will be having. These are 260. How many? 261 data points and their respective clusters. You can simply check this one as well. Yeah, that's perfect. These are the data points and their respective clusters. Like that, we will be forming the clusters. And now I want to visualize those clusters. You can simply check by k-means. These are the clusters. And if I want to visualize those clusters, in that case, I'm using the plot. We have imported that matplotlib, right? Using that, we can do the visualization. So these are the different clusters. Since we will be having 8, how many we have? How many dimensions we'll be having? 7. If we remove that label column, we'll be having 7 dimensions. In that 7 dimensions, it is not possible to view on 2-dimensional. That is why you'll be getting, this is a multi-dimensional data. Here, all those features, red color features belong to the US. I mean country, which country you're using? US is using, and blue that will be used by Japan. These are based on feature, different feature, which country are using those particular vehicles. We can form these clusters. So yeah, this is about k-means algorithm and how can we form. And if we, this is very basic model. We can do so many modifications, like we can apply normalization as well. Since the data help is having so much variance, right? Here we have 4,000 something, and here we have just single digit. In that case, what you can do, you can apply the normalization as well. Right after the normalization, you can fit to the machine learning model. So this is how we can do the clustering using the k-means algorithm. So that's it for today, guys. I hope you guys learned something. And if you want to kickstart your data science career, in that case, you can simply go to YouTube and search Tame Python by Bharani. You will be getting a playlist of 22 videos. Those are absolutely necessary to kickstart your data science career. That is a Python sessions. Those are very basic. So please, you can go through that. And if you want to see different domain analytics program, domain analytics videos, in that case, you can simply subscribe to 360DigiTMG. 360DigiTMG YouTube channel. And if you want to see more of transportation analytics videos, you can continue with this series. And yeah, thank you for watching this video, guys. And I'll be coming up with one more data set. I mean, one more use case using the KNN algorithm, and we'll be having decision tree algorithm also. Different algorithms we'll be having. For each algorithm, how this algorithm works, and we'll be taking one use case scenario. In the next session, that is on Monday, we'll be coming with one more algorithm and one more use case scenario, and we'll try to apply the machine learning algorithms in the transportation analytics. Yeah, that's it for today, guys. And thanks for joining, and we'll see you in the next class, and have a nice day.